Let us try to solve the same problem for experience by stored law. So, let us say K1 and M1, let us say K2 and M2. K1 in the given problem, you can see the problem, K1 is 2K and K2 is K, M1 is M and M2 is 2M. So, we will use that. K1 is 2K, M1 is M, K2 is K and this is 2M. Okay. Let us say assume deflection. We will assume the deflection at the mass points. Let us call this as 1.0 and 2.0. Inertia force, we will take M out. So, this is going to be 2 omega square, this is also going to be 2 omega square. Then we say spring force, again mass out. So, this is going to be 2 omega square and 4 omega square. Let us find out the spring deflection. So, divide this by the stiffness of the spring, this is going to be 2 omega square, because 4 omega square by 2 k is 2 omega square m by k, and this is going to be also 2 omega square. Now, let us say calculated deflection with m by k out, which is going to be 2 omega square and 4 omega square. Now, the values are 1.0 and 2.0. There is no convergence. We will take this as assumed deflection. Then we will compute the inertia force with mass out. This is going to be 4 omega square, this is omega square. Let us compute the spring force with mass out. This is going to be 4 omega square and 5 omega square. Then we say spring deflection, we say k out. So, 5 by 2, that is 2.5 omega square m by k, then this is 4 omega square m by k. Let us say calculated deflection with m by k out is going to be 2.5 omega square and 6.5 omega square. Let us find the ratio of 1 and 2.60. Again convergence did not happen, we will do one more cycle. We will say K1, M1, K2, M2, this is 2K, this is M, this is K, this is 2M. So, we have done this is the first cycle and this is the second cycle. Now, we are doing the third cycle of iteration. We say assume deflection. So, we assume this value as the third iteration start value. So, the values are entered the mass point 1.0 and 2.6. We compute the inertia force with mass constant. So, which is 5.2 omega square, this is omega square. We find the spring force, which is 5.2 omega square, 6.2 omega square, then the spring deflection with m by k. So, 6.2 by 2, that is 3.1 omega square m by k, this is 5.2 omega square. So, we say calculated deflection with m by k, which is 3.1 omega square with 8.3 omega square. We take the ratio, this is 1.0, this is 8.3 by 3.1, which is 2.67. We started with 1 2.6, we landed in 1 2.67. We assume that they are almost converged. We say that 1 plus 2.67 is actually equal to 3.1 plus 8.3 omega square m by k, is not, that is a constant out. So, now I find omega square as 0.567 root k by m, and the corresponding phi, the mode shape is 1 and 2.67. Let us compare this answer with what we got with the Rayleigh method. Rayleigh method says omega is 0.56 and 1 2.6, and this method says 0.567 1.267. Let us solve this problem also by influence coefficient method. So, it is very simple, I have to derive the influence coefficients from the first principles. Let us do that. This is going to be m 2m, this is 2k and k. Let us write the free body diagram. So, unit force. So, this is going to be 2k of alpha 1 1 and this is going to be k of alpha 1 1 minus 2 1. Similarly, for the second degree, give unit force here. So, this is going to be k times of alpha 2 2 minus alpha 1 2, and this is going to be 2 k of alpha 1 2. So, let us write down for the first degree, we say this is unity, this is unity. So, k of alpha 1 1 minus 2 1 is equal to 0, which implies that alpha 1 1 is alpha 2 1. Two k of alpha 1 1 plus k of alpha 1 1 minus 2 1 is unity. Substituting that this value is 0, you know alpha 1 1 will become 1 by 2 k, which will also give me as alpha 2 1. Now, for the second degree, k times of alpha 2 2 minus 1 2 is unity. Then 2 k of alpha 1 2 is k of alpha 2 2 minus 1 2. So, k of alpha 2 2 minus 1 2 is equal to unity. So, I can say this is 1, which implies that alpha 1 2 is 1 by 2 k. Now, we know alpha 2 2 minus alpha 1 2 is 1 by k. So, alpha 2 2 is 1 by k plus alpha 1 2, which is 1 by k plus 1 by 2 k, which I get this as 3 by 2 k. So, now I have the alpha matrix with 1 by 2 k constant out. So, this is going to be alpha 1 1 and 2 1 is 1 and 1, alpha 1 2 is again 1 and this is 3. And for this problem the mass matrix is m 0 0 to m. Now, write the control equation for iteration. We know it is going to be x 1 x 2 is actually omega square m by 2 k, because m and 2 k are constants in alpha and m matrices. So, m by 2 k, then I have to multiply alpha matrix with m. So, I get the first column as simply 1, that is this and this. So, 1, okay, and this with this is going to be again 2, and it is going to be 1 and 6 of x 1 x 2, because this is m and 2 m. Okay. Therefore, this is 1 2 and 1 and 6. Okay. Let us assume the iteration as 1 and 2, which is omega square m by 2 k of 1 2 1 6 of 1 and 2. So, this has a multiplier omega square m by 2 k of 5 of 1 and 2.6. So, the second iteration 1 2.6 omega square m by 2 k 1 2 1 6 of 1 and 2.6, which is omega square m by 2 k of 6.2 of 1 2.68. So, we take the next iteration 1 2.68 omega square m by 2 k 1 2 1 6 of 1 2.68. This gives me omega square m by 2 k, the multiplier of 6.36, and I get the vector 1 2.69. I do one more iteration 1 2.69 omega square m by 2 k 1 2 1 6 of 1 2.69, which gives me omega square m by 2 k multiplier of 6.38 of 1 2.69. I get the same converge value. Therefore, 1 will be equal to omega square m by 2 k of 6.38 of 1, which implies that omega is equal to 0.56 root k by m, and the corresponding phi is 1 2.69, no zero crossing. Therefore, first frequency and first mode shape. Let us compare this answer with what I got from stored law. So, 0.567 and 1267. So, 0.567 12.67. So, the answers are completely matching. One can also verify this with another method, which is given by Dunkerley, which is an approximate method which can also be used to compute only the fundamental frequency and not the mode shape. So, this says 1 by omega 1 square, that is a fundamental frequency, is sum of m I alpha I I. So, if I want to really find out for this problem, it is going to be 1 by omega 1 square, which will be equal to m 1 is m and alpha 1 1 is 1 by 2 k plus m 2 is 2 m and this is 3 by 2 k. This will give you approximately the value of omega. I leave it to you to compute this, but does not give you phi. So, as a summary, friends, in this lecture we learned Rayleigh method of estimating fundamental frequency and mode shape. We also learnt an approximate Dunker-Lee method of estimating only the fundamental frequency. We also solved a numerical example by eigensolver. Of course, I did not do it here in this class, but I hope you must have known to do it, but I solved it with stored law, with Rayleigh, with influence coefficient method, and we compared the answers and they were found to be in good agreement. So, the point is all these methods are computer based methods. They are easily programmable and they are iterative and hence needs computer method. So, in the next lecture we would like to give you the coding of these, solve a problem and then compare the results using computer code, which are exactly same as that of the results of what you got by hand. Thank you very much.